Now, anytime you have an equation with a degree that's greater than 1, you're going to start with bringing all the terms over to the other side. So in order to bring the 9m over to this side, I'm going to have to subtract 9m from both sides of the equation. And in order to also bring the 16m cubed over to the other side, I'm going to have to add 16m cubed since it's subtracted to both the sides of the equation. So now you see you can rewrite this entire equation as 27 minus 48m squared, and then the 9m came over to this side and became negative 9m, and the negative 16m cubed came over to this side and became positive 16m cubed, and you only have 0 on the left hand side, on the right hand side, sorry. Now I'm going to rearrange these terms, starting with the term that has the highest degree, 16m cubed, followed by the next highest degree, 48m squared, and then followed by negative 9m, and finally the constant, that's positive 27, equals 0. We have to factor this. Since this is not a quadratic equation, we're going to have to do some grouping. So I'm going to group the first two terms together and the next two terms together, and then try and find the common factors. So you'll see that in the first two terms, 16 and 48 have the number 16 in common, and m cubed and m squared have m squared in common. So we're going to have to factor that out. So I'm going to rewrite this as 16m squared. If I factor out 16m squared from 16m cubed, I'm just left with m. And if you factor out 16 from negative 48, you're left with negative 3. And since we factored out the m squared, that's all we have. Now, what about the next two terms? You'll see that 9 and 27 both have 9 in common. And since the second term doesn't have m, we can't factor that out. So what I'm going to do is I'm going to factor out negative 9. And if I factor out negative 9 from negative 9m, I'm left with m. And if I factor out negative 9 from positive 27, I'm left with negative 3 equals 0. I'm going to make a small note here that this is because negative 9 times negative 3 gives you positive 27. And that's why we have to keep in mind the negative sign. Now you'll also see that both these terms have this m minus 3 term in common. So I'm going to factor that out next. I'm going to rewrite this as m minus 3 times 16m squared minus 9 equals 0. We still have a little bit of work left to do because you'll see that this second term is not exactly a simple linear term, it's a quadratic term. But let me remind you now of the formula. A squared minus b squared can be factored as a plus b times a minus b. And you'll see that over here, 16m squared can be rewritten as 4 times m the whole squared, and 9 can be rewritten as 3 squared. So this is like a squared minus b squared, which means I can now rewrite this equation as m minus 3 times, remember this can be factored as 4m plus 3 times 4m minus 3 equals 0. Now, if you have three numbers that multiply to give you 0, it can mean only one of three things, that one of those three numbers must be 0, which means I have either m minus 3 equals 0, or 4m plus 3 equals 0, or 4m minus 3 equals 0. This makes my work a lot easier because now I just have to deal with linear equations. So I'm going to solve this linear equation by adding 3 to both the sides of the equation, and that gives me that m equals positive 3. To solve the next equation, I'm going to subtract 3 from both the sides of the equation to isolate the m. So I get 4m equals negative 3, and then to find out what m is, I divide by both the sides by 4. On the left hand side, I can get rid of the 4, and so I get m equals negative 3 over 4. The exact same way, when I take this negative 3 over, I get 4m equals positive 3, and then divide both the sides by 4, and you get m equals positive 3 over 4. So you have three distinct possibilities for the value of m, and so your solution is given by m is either 3 or negative 3 over 4 or positive 3 over 4.